Hello and welcome to the third video of our Markov chain series. In this video, we'll start with something basic and later introduce nth step transitions. Let's start with something simple as converting a transition matrix into a state transition diagram. Here we have a matrix with three states, state 1, 2, and 3. I've labeled the sides of the matrix, but what we need to know is which ones are our outgoing states and which ones are our ingoing states. As we discussed in the previous video, the outgoing probabilities from each state add up to 1. Here, if you look at the rows, you can see that the numbers in each row add up to 1, 0, 1/4, and 3/4 is 1, and 2/3, 0, 1/3 is also 1, and it's the same for the last row. And from this, we can conclude that these are our outgoing states and these are our ingoing states. And from this, you can draw the state transition diagram. All I did was read from the matrix. So if you see 1, 1, we have 0. So there is no arrows for that. And then from state 1 to state 2, you have 1/4. And that is represented by this arrow right here. And that is how you translate a matrix into a state transition diagram. This is helpful if matrices confuse you and you want a visual representation of the situation. Plus, state transition diagrams, in my opinion, are just easier to read compared to matrix. So now we can move on to nth step transition. But what is nth step transition? It's basically the probability of going from one state, let's call it I, to another, let's call it J, in nth steps. Right here. So let's think of one situation of let's say going from state 2 to state 3 in 2 steps. Can you think of ways you could do that? So the first way is by going from state 2 to state 1 first, and then you have 2/3, and then you go from state 1 to state 3, which is 3/4. Another way you could do that is by going from state 2 to state 3, which is 1/4, 1/3, and then you self-loop back to state 3, which is 1/4. So you basically calculate the two different paths, which you do just by multiplying the 2 steps or however many steps you take, and then add the 2 paths together, which I have done over here. 6/12 plus 1/12 equals 7/12. Another way we can do this is through matrix multiplication. If you multiply a transition matrix A, or any matrix in general, to itself nth times, you can find the probability of going from state I to state J in nth step, and which is represented by this notation right here. So the final matrix, which I have over here, is AN, and then you think of the problem that you want to solve, which, as we did before, which was from state 2 to state 3 in 2 steps. That's why we multiplied the matrix twice over here. And let's look at it. From state 2 to state 3, we have 7/12. And if you remember, we got the same number before, which is right over here, 7/12. So these are 2 ways you can calculate nth step transitions, but obviously that is not all. For example, if you have a 10th step transition and you can't really do matrix multiplication, it would get really complicated. but that's just how it is. It just gets more complicated here on. You have more complicated equations and more complicated terms that you have to know. But this is a beginner level series. So this is all I have for you today. Thank you for watching.